All right, let's go ahead and do this. Plate boundaries. Put your phone away, darlings. Please put your phone away and your AirPods and earbuds and all of that. TOC. All right, so this is, whoops, you can't see that, my bad. Here is your plate boundaries and landforms. If you could write that down, I would greatly appreciate it. Today's date is 12/21, and it's going to be page 23. To the best of my ability, I believe that's what it is. Last day. I mean, not ever. Last day until Christmas party. I know, me too. My husband dropped me off this morning with the 4-wheel drive so that just in case it started getting yucky this afternoon, I'd be able to get home okay.
I don't even know what it's
Your table of contents?
I'm sure it's a fit to me, girl.
All right. Let's go ahead then, and this is what it looks like. It's what you picked up on the way in. I'm going to go ahead and pull up that. Actually, I'm going to take attendance real quick. Y'all excited about the last day? Did anybody get to see any of the singing? In the main commons area, they have singing. Did anybody get to see any of it? Oh, it was very lovely. The singing was very lovely. All right, let's see. Who's missing? Who's missing? Who's missing? Alex went to the restroom. Logan is here. Those two people are one person gone. Great. Oops, sorry. Probably can't see that. I apologize. Let's see if I can get rid of that for you. Plate boundaries and landforms. It's just the title, honey, that's on the sheet of paper you picked up. All right, my dears, let's do this. There's two types of plates. I'm going to turn down the front light so that we can see this a little better. There's two types of plates on the earth that we're going to deal with. One is ocean plates, and those are plates that are below the ocean, so that makes sense. And then the other one is continental plates, and these are plates that are below the continents. So that should be easy for you to remember. Make sure that you're writing that down. There. Ocean plates and continental plates.
Pulled it out of nowhere because I'm thirsty.
All right, let's move on to the next. We're going to talk about the boundaries between those two plates. One is divergent boundary. Divergent boundary are between two plates that are moving apart or rifting. Rifting, think about it as like ripping. If a plate is rifting, it's ripping or moving apart. You're not writing anything down, and that's worrying me because I can't wait for you to catch up. Rifting is what causes seafloor spreading. We talked about that the other day. and the plates are moving apart. If you want to go ahead and, I don't know, did I put the arrows there for you on the note sheet?
Yeah.
Okay. Features of divergent boundary. Remember yesterday when we did our reading, there was like features and then there was processes. So features are going to be like the thing, the land masses. And so a feature at a divergent plate boundary is going to be a mid-ocean ridge. If you see ridges, you know you're at a divergent plate boundary. If you see a rift valley, notice the word rift, like rifting. Rift valleys, you're at a divergent plate boundary. Volcanoes can be at a plate boundary that is diverging, but it doesn't necessarily mean that it has to be a divergent plate boundary. But at a divergent plate boundary, you'll see volcanoes. Has anybody ever heard of the Great African Rift Valley? What's up, bud?
The Ring of Fire.
Ring of Fire, that's right. That's all divergent plate boundaries, the Ring of Fire. Polynesia, that kind of stuff. African Rift Valley, has anybody heard of it? No, Great African Rift Valley, okay. So here's a picture of the the Mid-Atlantic Ridge. We've got that here. You can almost imagine if you see this whole kind of puzzle piece and this whole puzzle piece. Just imagine like if we reverse it and smush all of this together. It was all connected land at one time before that land in the middle started rifting or ripping apart. Another picture. This is the African Rift Valley. It's this little subset right here. Notice the Red Sea. Have you ever heard of the Red Sea? Okay, so the Red Sea right here and the Gulf of Aden, this used to be connected land. But what happened was this started rifting. And so as it's rifting, at first it was just a big lake. And then when it gets connected to the edge of the continent and ocean water rushes in, that's what becomes a sea. This is continuing to rift right through here. We've got these long finger lakes. Imagine that this is once what the Red Sea looked like. And then as this continues to rift and connect up to the ocean, we're also going to see this water rushing in over here and then over here. And so this is all going to eventually be separate land. And this is just going to kind of, move itself away from Africa. Notice also lots of volcanoes. There's lots of volcanoes that are happening because the land is getting stretched. It's getting pulled away and stretched, and so it gives opportunity for magma to come up and volcanoes to form. Here's a picture of Victoria Falls. Has anybody ever heard of that? Has anybody ever heard of the movie Up with the little balloons and the man with the house? So he wanted to land his house at Victoria Falls with his wife. This is what Victoria Falls is. And there's another picture of it. Lovely. It's beautiful. You can see that rifting land. Again, more pictures from above. You can see kind of like the big cracks that are happening in the land. Okay, here is a picture of what happens with rifting. You've got magma that is punching its way through the continental crust. Kind of like if you have a sheet of plywood, and if you push that sheet of plywood or bend that sheet of plywood, you're going to get cracking along the plywood. That's what's happening right here. Look at all of these little cracks that are allowing for magma to come up, and you've got volcanoes forming. So imagine that this was like South America and Africa at one time. And then you've got these fault block mountains that start to be created and big plateaus as these, imagine these are like books standing up, like these things, and as it's being pulled apart, they kind of start slumping like this. And you can see these little steps. And so that's what happens as it continues to get thinner and thinner. And then eventually it moves apart, and it'll either fill up with fresh water, or the sea will come in and it will then become a sea and then eventually part of the ocean. It's called a linear sea because right now it just kind of looks like a nice thin like lake. So that's what happens. And so again, right, this is what happened to South America and Africa. Think South America over here and Africa over here. Okay, next is convergent boundaries. These are boundaries between two plates that are colliding or collision or coming together. And there are three types of convergent boundaries. The first one is when an oceanic plate collides with a less dense continental plate. So we've got the more dense oceanic plate. Remember with our density of earth materials lab, we found out that oceanic materials like basalt are much more dense. They've got a high level of iron and magnesium in them. So it's much more dense than continental plates. Continents are made of things like silica, which has a lower density. So at a subduction zone, another word for zone is area, an area of subduction where the more dense oceanic plate slides under the less dense continental plate. So that's kind of like this. If you were going to draw a picture, and it might not be a bad idea if you do that along the side, you've got your oceanic plate, and it is going to be diving underneath your continental plate. This is going to be more dense right here. And so as that happens, this oceanic plate, as it's going into the mantle, because it's hot, starts melting, and it kind of goes up through the cracks. That's why you get lots of volcanoes at subduction zones. Lots of volcanoes at that area. Like this. So you've got the oceanic crust, which is more dense, and it is being subducted. This is that slab pull underneath that continental crust, which is a lot less dense, and it's melting and rising up that magma, and then what it does is it forms these volcanic arcs. Like what are those mountains called? The Andes Mountains on South America. Like this. Yep.
So then, as the Pacific plate goes under the South American plate, will the Andes Mountains just get taller and taller?
It's just, yeah, they're going to go ahead and continue to be, yeah, I would think so. I mean, you know, the volcanism will continue, and they will definitely continue to erupt as long as there's material there. And there's our beautiful Andes Mountains of South America. So it says example. An example would be the Andes Mountains in South America. And that is that volcanic mountain chain that you saw on the map all along the edge of the map of South America when you were looking at your map. Good? There's a video about it. We're not going to watch it. It's just showing all the different Andes Mountains. Yes, they're gorgeous. Nope. Nope. All right, type 2. You've got your more dense oceanic plate colliding with another oceanic plate. So wait, if they're the same density, how then does it say the more dense plate slides under the less dense plate, creating a subduction zone called a trench? Well, I'll tell you. It's because one of the oceanic plates is going to be older and colder than the other oceanic plate. So if this whole thing is underwater, and this is oceanic, and this is oceanic, what we've got is this is the old, more dense plate. It's been around longer, it's older, it's colder, and so because it's older and colder, it's going to be more dense than this younger and newer, less dense oceanic plate. And so what happens is the same thing as the Andes Mountains. You get a mountain chain called an island arc, that it's just like mountains that have their heads stuck above the water. Yeah?
Is that how Hawaii was created?
That is not. Hawaii was actually created through a hot spot. You get this big mountain, this big plume of magma that punches its way up. And as the crust moves, the plume of magma kind of stays in one place. I wonder if I can show you that. I can't right now, but I will show you when I start teaching you about volcanoes. You'll start learning about how that's created. So here's a picture of what that looks like. It's the same process. You've got your oceanic crust diving under. You've got oceanic crust right over here. And what happens is you've got that same melting process, and you've got those mountains that are being created, except now that because water's on top of them, it's just the tops of the mountains that are sticking up. And so those to us are islands. The Aleutian Islands are an example off of Alaska. Gosh, what's that? Greatest catch or most dangerous catch, or what's that fishing show where they catch crabs? Deadliest catch. That's it. Deadliest catch. They go fishing around the Aleutian Islands. Another example would be Japan. So if you want to write down an example of Japan, this plate is diving underneath, and it's creating these islands right here of Japan. And you're going to have lots of volcanoes and earthquake activity. Lots of earthquake activity in that area. On November 22nd, 2013, a new volcanic island appeared south of Japan, and so we're going to watch this go ahead and grow. So this was 2013, where it just kind of poked its head above the water. So imagine how large it is under the water. There were 5.3 million cubic feet of lava that came out every day. Ships have to stay about 3 miles away from the island. And so in 2013, this is what you can kind of see. This was where it was growing, and it was kind of moving out in that direction. And then in 2014, you can see how much it's grown, so that now it's connecting with the other island that was next to it. And then 2015 is where we are here. That's kind of, I think, where it was and then where it is. And then this is what it looks like again in 2015. We can see 2016, so it's just getting bigger. Okay, type 3. This is where you have a continental plate and a continental plate coming together. These are the same density. So in this case, you have continent with continent, and what's going to happen at the front is a very slow-moving collision, and you are going to get these folded mountain ranges that are going to happen. So again, it's an area of collision or a collision zone. And the reason they call them folded mountains is because the underlying geology is all folded up. And you also get thrust faulted mountains. Thrust just means that it's being uplifted, being pushed up. So I'll show you some pictures of that. Good? So this is that situation. This is the Himalayan Mountains. This would be like the continent of India has smashed into the continent of Eurasia. And imagine in a scenario like this, if you have like a splinter under your fingernail, that's what's happening. And so Eurasia is the fingernail, and India is the sliver that's just shoving itself underneath the fingernail. And so this is raising up. That's why it's called the high plateau, because this landmass is literally shoving this whole land up. So you've got this like sliver being jammed right underneath your fingernail. This is still, India is still moving forward, and so it's causing these mountains to crumple up and raise higher and higher by about 2.5 inches a year. Eventually, this will weld together in what's called a suture zone, like, you know, if you get stitches, it'll suture together, and then these two land masses will become one big land mass. But for now, India is still driving itself forward and under Eurasia. And this is the process. Remember how I told you we found seashells at the top of the Himalayan Mountains? So this is why. Because as India, the landmass, 71 million years ago, right, there was a lot of ocean between it and the Eurasian plate. Well, slowly, over millions of years, it got closer and closer, and look what happened to that ocean in between. It got smaller and smaller. But there's a lot of material at the bottom of the ocean that just got slammed and caught up in this little area right here. This is like an accretionary wedge. Notice it's a wedge shape. And so we're able to find ancient marine animals in the Himalayas because at one time they were like that at the bottom of the ocean. All right, there's the Himalayan Mountains, tallest mountain in the world. I think that's Mount Everest.
Wow.
Gorgeous. All right, transform fault boundaries. I want to let you know at this time, fault is just another word for like a big crack, right? Fault is like a broken piece of rock. So these are boundaries that are between two plates that are sliding past each other. There's a lot of earthquakes that are associated with these faults, but I want you to know that earthquakes are not only associated with transform faults. Earthquakes are associated with all movement of plates. Anytime you get a big piece of land grinding past another piece of land in one way or the other, it's going to cause earthquakes. And an example of that is our San Andreas Fault. And so you can write down the San Andreas Fault if you want. There's another picture on the next page I'll show you. So this whole area is moving up like this towards Alaska and the Aleutian Islands. This is the Baja Peninsula of California. Eventually, this piece of land will no longer be on North America. It'll just be carried up and just follow this line up and around, and then eventually smash into the Aleutian Islands and add land to that area. If you look at the geology or the rocks of this area of North America, you will see that this is just one landmass of many, over millions of years of islands and different pieces of land that have smeared itself and left little pieces of itself as they were kind of going on their way by. It's kind of cool. And there's the San Andreas Fault. If, again, you need a bigger example of how to write down where it says example, San Andreas Fault is there. Anybody been to California and seen it? Me either. Someday. Lots of earthquakes associated with faults. There's all kinds of faults. So it's not just that we have only the San Andreas Fault. If we could look at all of the faults in this area, there's just several different broken pieces of land. Okay, what are the three main types of boundaries, or what are the three types of boundaries? What's the first one that begins with the letter C? Convergent boundaries. What direction do plates go for a convergent boundary? Anybody? Oh, convergent, towards each other. Okay, what's the one that goes away from each other? Divergent. What's the one that slides by each other? Transform. Which boundary has a subduction zone? Convergent. They're colliding with each other, and one is going underneath the other, subducting. If you want to think about subducting as in I'm ducking underneath the other one. Subduction. And at a subduction zone, you get deep ocean trenches and also big earthquakes. Okay, let's go ahead and talk about factors that cause plate tectonic movement. Factor number one is gravity. Earth's gravitational force is always pulling objects towards the center of the Earth, even the tectonic plates. This is most noticeable on an oceanic crust where the ridge is uphill from the trench. So the ridge is higher up and the trench is down below, and so gravity is just going to, kind of cause this to slide down into that trench. I was talking to my husband about this. I'm worried about all the snow. We just got solar panels on the roof a couple of years ago, and I'm really worried that with all the snow they're expecting us to get, it's just gonna, hurt the solar panels. That'd be silly though, right? It's gonna slide right off and smash whatever's on the ground. It's gonna be great. Okay, density. The more dense a plate is, the more likely it is to sink. Oceanic plates, Brayden, oceanic plates are more dense than continental plates, right? That's that part of density of Earth's materials lab we did. This is why oceanic plates are subducted underneath continental plates. It's that slab pull. They're being pulled underneath. More dense always under less dense. Continents are kind of like corks floating on water. Has anybody ever tried to push a cork underwater? Well, if you do, what's going to happen to it? Right? It's going to come back up. So imagine that the continents are like these giant corks kind of floating on the mantle. They are not dense enough to go into the mantle ever. And so they're just going to always rest on top. Back hurt? It's posture. Or sloucher. Me too. All right, third, convection. going on in the mantle. This hot magma in the earth moves towards the surface, then it cools, which makes it more dense, and it sinks back down again. And these currents are moving really slowly, about as fast as your fingernails grow. And so it's the slow movement of these currents, these convection currents, that cause the plates to move. And they're either going to be pushed away from each other or pulled towards each other. All right, let's do a little review. Well, here's that kind of process. And so I will, on the next quiz, or definitely the exam, you'll have different currents, and I'll say, hey, what kind of a boundary is at part A, right? And you'll have to look at the currents to figure out, are they moving towards each other, away from each other, and then look at that. Okay, what causes plates to move? Could be what? Could be convection. Popcorn it out. Tell me what else. Could be gravity. Could be density. Nice. Okay, here we go. Divergent boundary of two continental plates creates a, right, rift valley. An example of a rift valley that we talked about? The Great African Rift Valley. This is where Mount Kilimanjaro is. Mount Kilimanjaro, anybody ever heard of that? Yeah, Mount Kilimanjaro, right? That is on the African Rift Valley. It's a very big mountain. So the East African Rift Valley. Okay, convergent boundary of two oceanic plates creates a trench and an island arc. So that just means you get these volcanic mountains with little tips of them sticking out of the water. Example they gave us was Japan, or you could say the Aleutian Islands in Alaska. They're off of Alaska. Okay, convergent boundary of an oceanic plate and a continental plate forms a, what kind of a mountain range? Volcanic mountain range. You can see that, like the Andes Mountains. And it also forms a trench. Anywhere you see subduction, you get a trench. The Andes Mountains. Okay, a convergent boundary of two continental plates, same density, forms what kind of a mountain range? Folded, and look what's happening to all of the layers of the earth underneath. This is why it's called a folded mountain range. They're just kind of crumpled up. Examples of this would be the Himalayan Mountains. And transform fault boundary, where the North American and the Pacific plates are moving not towards each other, not away from each other. They're just kind of sliding past each other. So they're sliding past each other. And examples in North America would be the San Andreas Fault. And that's it. Dun, dun, dun. Now we're going to have a quiz. Just kidding.
I would like to quit.
I know you would, honey. No, we're not having you quit. All right. We have so much time left. So what I would like to do is I want to give you some time. If you have anything to make up, like if you want to do, I don't know, type me a essay, you can do that. Or while that's happening, I want to go ahead and watch a little Disney special.
Can we sing happy birthday?
Can we take a look?
It's not your birthday. It's tomorrow.
I don't know what she wants, but the answer is no.
Don't be like that. Don't be like that. What? Yeah, get the vocal out. Get the vocal out.
Mine would be yeah, you can make it.
Please don't go home alone. I'm sick of that. There's many teachers that put that on so far this week.
Everybody's going down to the gymnasium
Please
to
don't.
watch our new
I think you put it on this week.
We're gonna play some 9-year-old shit.
What? Right. First or whatever you said, or I was like, is that a good? Because all I see is him.